Good day, everyone. My name is Tulalo Murray, and today we will be presenting Brownfields evidence collection. And my team members include Lawrence Mansa, Tatomo Kovali, and Garabu Kunu. About the project. This project involved the use of a code base from the object-oriented programming module, reflecting real-world conditions with varying code quality and design. We have the server side, client side, and the protocol and interaction side. With the server side, it acts as the control hub for a dynamically constructed robot world, which is responsible for managing multiple robots simultaneously. It also processes commands from robot clients, updates the world state, and maintains all interactions within a configurable world grid world. The key elements include handling visibility, managing obstacles and bottomless pits, as well as allowing various robot actions, such as moving and attacking based on server-defined rules. On the client side, the client program enables users to connect to the robot world, launch robots, and command them through a network. The robot, upon entering the world, starts with no prior knowledge of the environment and learns through exploration. Commands from the client to the server include movement directives, attack initiation, and world observation, with the server providing feedback based on current world conditions and robot actions. On the protocol and interaction, we have both the server and client adhere to a standardized messaging protocol and ensure interoperability across different team environments. This protocol includes structured requests and responses that facilitate consistent communication and world interaction. For documenting our project, we used the readme.md file, which is stored in our repo. The readme.md file has the project overview, and it also has key features, which highlights the multi-client server architecture for concurrent connections, the game logic implemented on the server to manage robot world states and actions, the HTTP API layer for external command reception and integration, the console client interface for direct user interaction with the game environment, as well as custom communication protocol, which ensures seamless integration between clients and the server. The protocol is implemented in JSON format. In order to get started, you need to clone the folder. So this is the command for get cloning the folder. And there's also prerequisites that you must adhere to, such as having a Java that's 11 and above, a Maven 3.8 or above, a Make, and a SQLite 3. To run the robot world server, you can run this java jar command, and you can also add server command line commands such as the port number, the world size, visibility, repair, and etc. To run the robot world client, you also need to run this jar command here, and then you can also add client command line arguments such as the port number or the IP address, or you can use the default value, which is the local host. This application comes with different types of robots. We have the simple robot, the sniper robot, shooter robot, and the bomber robot. For client commands, we have a command to launch a robot. We have a command to move the robot forward or backwards, to turn the robot left or right. You can also look at the state of your robot. You can also run the loop command as well as reload and repair. For the server console commands, we have command to show all objects in the world, to show all robots in the world, to remove a robot from the world, and etc. And we can also do project planning. We began our project by thoroughly analyzing the existing code base and clearly defining the project requirements. To align our understanding of user needs, we crafted detailed user stories, which guided our development process. Adopting the test-driven development (TDD) approach, we first wrote unit tests and acceptance tests, gaining a deeper understanding into the functionalities we were developing. Before diving into coding, our team established a shared understanding of the requirements and strategically decomposed the project into manageable iterations. We employed a code analysis tool called CodeScene to identify and prioritize hotspots in the code base needing agent refactoring. This early detection allowed us to refine these areas effectively, ensuring they met the original project specifications. Development progressed in sync between the server and client sides, with both components being built simultaneously to maintain coherence. As the project evolved, we integrated a web API and database, enhancing the system's functionality and interaction capability. This method and iterative process not only streamlined development, but also ensured robustness and responsiveness in the final product, setting a solid foundation for future enhancements.
Good day, everyone. My name is Lawrence Mansa, and I will be taking us through software development and source files. In managing the source files for our project, we utilized GitLab in conjunction with Git, two essential tools that streamline version control and collaboration in software development. Git is a distributed version control system that allows individual developers and teams to track changes in source code during software development. Its functionalities enable us to maintain various versions of our project, ensuring that we can revert to previous states if needed and work on different features simultaneously without conflicts. GitLab, on the other hand, is a web-based DevOps platform built on top of Git. It not only provides a centralized repository for our code, but also enhances the collaboration amongst team members. Through GitLab, we were able to leverage features like issue tracking, continuous integration, continuous development, and more, which significantly improved our workflow and productivity. All right, so to demonstrate that we can retrieve and update source files and protect these files in the same process, we'll perform a git pull command to pull all the updated files into our project. So as you can see, you're in the project folder, and right now we are working on the main branch. So to get all these files, we perform a git pull command. We enter our credentials. All right, and already up to date. As because I've been working on this project, I am already up to date, but we will do a minor change and over to our IDE where I will make a change to this web API tests.java file, and we'll just add in a few comments such as what we are going to be doing here, whereby we create a mock instance of the web API handler, and from there we create a mock instance of, I think I spelled instance wrong, right? Yeah. And we can save these changes. And once we save these changes, we can check the status of our repository, and then obviously git add all the changed files. From there, give a git commit with a message. And of course, we can then perform a git push after giving our credentials. And we have successfully pushed back to our repository. So coming back to our repository, the home of our repository, you can see that my commit is just running and the pipeline is just doing its thing, but I'll take you through our source code files. And as you can see, we have two main package. We have a main package and a package for testing. You can enter the main and you'd see there's a package for the API, the client, the command, the JSON handler, the server, the database, and so forth. Moving right along, you'll be able to see that there are two packages, one for the acceptance test and one for the unit test, where we just added a comment there. So moving right back to the home page, you'll be able to see that the pipeline is currently in its building job. From there, it will go to its packaging, unit testing, and so forth. Code and design conformance. To demonstrate that our code base is created to specification, we will begin by having a look at a few classes that we created. The Web API and Web API Handler work together to provide a functional API for a web-integrated application managing a robotic world. Web API sets up the server and routes, determining how requests are directed within the application. The Web API Handler as the operational core, handling the business logic and interaction with the world state based on API calls received. This architecture separates concerns between the server management Web API and the application logic web API handler, aligning with good software development practices. This separation allows for better maintainability and scalability of the code, making it easier to update the handling of world states or API responses without touching the server setup and vice versa. The client class handles the establishment and management of a socket connection to a server, facilitating the sending and receiving of requests and responses. It integrates a variety of functionalities from initiating a robot to handling continuous game interactions. So some of its key functionalities would be like connection management, where the client can connect to a server using a specified IP address or port number. It can also manage the connection state and also gracefully disconnect clients from the server. The second functionality would be request handling, whereby the client is able to send JSON formatted strings as requests to the server and parse responses. The send request and send request as a string method handles these operations, ensuring that commands sent to the server are correctly formatted and responses are appropriately processed. Looking further, you can see the user interaction as the class prompts users to enter a command via the console, pro- processing the commands and sends them to the server, and also displays the server's response back to the user, facilitating a dynamic interaction as the game progresses. So, response and look, this is the greeting message, and this is the main function. All right. So the two Java classes, Simple Server and Server Handler, serve key roles in managing a multi-robot simulation environment via a server setup. We'll begin by taking a closer look at the Simple Server class, whereby the class functions primarily to manage individual client connections within the server. It handles connections between the server and client through a socket connection rather. So its key tasks or the key functionalities or major tasks for the sample server would include receiving and processing commands as it's doing in this line of code here, whereby it listens for a message from a client, processes these commands through the world simulation, and sends back responses. So some of these commands might include robot actions that affect the game state. What it also does is it also does some error handling where the class gracefully handles errors and exceptions, providing robustness to the client server interactions. The server handler class manages the overall server environment, handling tasks such as server setup management, whereby it initializes the server socket and starts listening for incoming client connections. It handles the creation of simple server instances for each connection and manages these threads. It also has some world management, where the class is responsible for creating and managing the world objects that contains the game state, including robots, obstacles, etc. So we also have the web API integration, where it integrates with the web API to provide additional functionality by web-based client interaction or administrative tasks. So it also does session management, whereby it ensures that all resources are properly closed after shutting down, maintaining the server's integrity and performance. So the connection between these two classes, specifically simple server and server handler, would be, for example, the client handling, whereby the server handler uses the simple server to handle individual client connections. When a new connection is accepted, server handler instantiates simple server to manage the connection with the particular client. And when it comes to shared resources, both both classes interact with the world object. Simple server processes commands against this shared world state, and server handler initializes and manipulates the world state. So now to identify methods of accessing data within our program, we'll have a look at our dbconnect.java class, whereby its its purpose is basically to establish a connection to a SQLite database, either stored in memory or on disk, depending on the command line arguments provided. The class includes methods to create a test table showcasing basic interaction with the database. So its key methods are the run test method right over here, and this method executes SQL statements to create a new table demonstrating base SQL execution. And looking at the next function would be the process command line arguments, which configures the database URL based on input parameters, switching between an in-memory and a disk-based SQLite database. Right along, we can then have a look at our database interface, whereby its purpose is basically it defines an interface for our database operations related to a world in the simulation, stipulating methods for creating, reading, updating, and deleting world configurations. So its key methods are basically to create, to read, to update, as well as delete. All right, so now having a look at our world database class that implements the database interface, what it basically does is it manages the persistent storage of world configuration. It handles complex operations involving both world data and associated objects within the world. So some of its key method would involve this method here, create, whereby it inserts a new world or updates an existing one based on the provided configuration. Another one would be the read function here, where it retrieves the configuration of a specific world. Moving on would be to update the configuration of an existing world and to obviously delete the configurations of a existing world. We then have the function that creates the tables and drops the tables as well. Another class to look at would be our world database access object, or our world data access object rather. So the purpose for it is basically to act as a data access object for the world entities. It utilizes EOD SQL queries to interact with the database, simplifying crude operations by mapping them to method calls. So its key functions would be managing the database schema for storing world information, also inserting and updating records in the world table, also for deleting world and retrieving world's IDs, respectively. Overall, these classes form a comprehensive system for managing database interaction in a structured and organized manner, facilitating the maintenance and manipulation of complex data structures needed for the simulation of our game and its environment. Straight that the names created in the program describe the purpose of the items name. We'll have a quick look at our directions enum class, whereby you can see we have specified the directions as north, south, west, and east. Straightforward, simple as it comes. Moving on to our positions class, you can then see for position we required an x coordinate, which is declared private final, as well as a y coordinate, which is private and final as well. So to create a position, both this x and y coordinate will be mandatory, and we can also retrieve x and the y coordinate from the positions object. We can then also have a closer look at the naming convention of our commands. All our commands are named according to what they do. For example, pack command, and it extends command. If we look at the abstract, the abstract class command, will be able to get a few of this information, whereby you can see this class called forward command performs the forward movement, back command performs the back movement, the launch command launches a robot, state command retrieves the state, and so forth. To show that our project conforms to the design documentation and outlines the differences with the reasons for the deviations, our project went accordingly to design. There was no need for any deviation, and therefore we did not have to document any deviations for our project. So yeah, stress testing. Stress testing is crucial for a project like this to ensure that the system remains stable and performs reliably under extreme conditions. In the context of this robot simulation environment, stress testing would involve evaluating how well the server and client components can handle high loads and whether they can maintain their functionality when pushed beyond normal operational capacities. Now, this is why stress testing is needed. Number one, handling concurrent requests. The server might need to manage multiple client requests simultaneously. Stress testing can help identify the server's capacity to handle numerous concurrent actions without performance degradation. Number two would be the robustness and stability. By simulating high loads, stress testing can reveal potential weaknesses in the system that might not be evident under normal conditions. It ensures that the server can manage peak demand without crashing or losing data. Performance bottlenecks. Stress testing can uncover performance bottlenecks in the system architecture, allowing developers to optimize the code or infrastructure to ensure higher loads efficiently. Client-server interaction. It's crucial to understand how the client behaves under stress, particularly how it manages queuing and processing for the server's response when the server is slow or overloaded. Real-world readiness. Especially in a simulation environment where real-time interaction is key, the system must perform reliably under varying loads to ensure a consistent user experience. Entered our IDE, where we can see and have a better look at the structure of our project. We have a package here called tests, and this is where we saved our acceptance tests as well as all the files for our unit tests. So what we'll do is we'll use JUnit as a testing framework to run these tests, both acceptance and unit tests. And there you have it. Out of 68 tests, we ran 68, and all 68 have passed with 0 errors and 0 fails. So for our project, the user expected a few things from us. Number one would be to connect to the server. Number two, to launch a robot within the world. Number three would get the state of the robot. Number four, to look around. Number five, to move. Number six, to fire shots towards other robots. Now let's have a quick look at the demo. All right, assuming that there is a robot world server running successfully, we can run this jar file called the robot world client.jar, which comes with a package for us to actually connect to a server. Once we have connected successfully to that server, we are greeted with this beautiful graphic that welcomes us to Robot World, and we'll get into launching a robot. So to launch a robot, we specify which robot we want to launch because they all come with their different attributes. From there, we specify a name, like my robot will be James. We then get a successful a successful response from the server telling us that James has been launched into the world. We also get the world data telling us the dimensions of the world, which is 100 by 100 world, with the visibility, the reload time, mine time, and everything else. Upon that information, we also get the robot state. So what we can do right now is we can move forward 20 times. And as you can see, I've been obstructed. I can't move. To find out why, we can give the look command. The look command provides this information. These are the objects in your visibility. So we have an obstacle to the north. It's 2 units or 2 steps away from us. We have a pit, which is to the south, and that's about 4 steps away from us. And then we get the robot status as well with a shield of 10 and 5 shots. So now, to fire a shot, we'll give the command fire. We get the response from the server telling us that it's a miss, as well as the state of the robot, which tells us, as you can see, we fired 1 shot. We had 5, we fired 1, we have 4 remaining. We can also turn left. We get a successful response from the server, and also the state of the robot, which tells us that now our direction is west. All right, so now we are in the home of our repository, and to get this program running, you'd need Java 11 and above, you'd need Maven 3.8 and above, you'd need Make, and you'd also need SQLite 3 if not installed already to get the server running. Rather, you'd need to be in the home directory and prompt this command in the terminal, which starts up a jar file named robot world server, and you enter your command line arguments. To get the client side running, you do the same in the same file and run this command here, which starts up the robot world client.jar with command line arguments. The documentation in the readme.md file certainly includes the overview of the project, which stipulates that it's a multi-client robot world server. This project is a multi-client server program designed to facilitate robot control in a game environment, and users can connect to the server and control robots, perform actions such as moving, shooting, and laying mines. The server features an HTTP API layer to receive commands externally, in addition to a console-based client for direct user interaction. To view the layout of the code, we will simply access our source file, and you will see there are 2 packages. We have the main folder as well as the test folder. In the main folder, that's where the code for the API client, commands, and everything else that follows, that is where that code is stored. And going back into the test folder, you'll be able to see that we have 2 packages, one for acceptance tests and of course the other for unit tests. Other programmers can definitely analyze our code by accessing our build pipelines to see the shape and how the code has taken shape over time. You can see that we've ran some tests, and unfortunately some of them have failed, and over time we've managed to work our way up to get successfully running tests. You could also take a look at the repository graph itself to view that the code base has taken and changed structures over time. And yes, tests can be rerun over time. Coming back to our pipelines, you'd be able to see that tests can be rerun over time under the same conditions. So under the same conditions, you can see, as you can take a closer look at the stage, we had the build job, the package development, the unit tests ran and they passed. We also have the acceptance tests that ran and passed. We package released and we deployed, all of that passed. You can also take a look at what failed, such as these acceptance tests failed and the reason as to why they failed. All of this is documented and saved within our repository.
Database management system. So let's start with what is it? So computer database management systems are crucial systems that enable users to define, create, maintain, and control access to databases. They provide a systematic and organized method of managing data in various formats. The key features for a DBMS include data integrity, which ensures accuracy and consistency of data through constraints and rules. The second one would be data security, which controls access to data, ensuring only authorized users can perform actions on the database. The third one would be backup and recovery, which provides mechanisms to recover data after accidentally loss or corruption. Then we have concurrency control that manages simultaneous data from preventing conflicts and data integrity. Then the last one would be query processing, which allows users to query the database and retrieve data. The database management system addresses key data management issues through its comprehensive features, enhancing data integrity, security, accessibility, and efficiency. Here's a summary of how a DBMS tackles these challenges. Data redundancy and inconsistency. DBMS minimizes data duplication and ensures consistency through normalization, reducing redundancy and enhancing reliability. Data security. It implements robust security measures like user authentication, authorization, encryption, and access controls to protect data from unauthorized access. Data integration. DBMS offers a unified platform to integrate and manage data from diverse sources, ensuring cohesive, consistent data views. Data concurrency, data access. Through transaction management and locking mechanisms, a DBMS allows multiple users to access data simultaneously without compromising its integrity. Data backup and recovery. It provides tools for backing up data and recovering it in case of loss or corruption, ensuring data availability and resilience. Commercial DBMS features like transaction management, performance optimization, scalability, data warehousing, and customization further reinforce these solutions, allowing organizations to manage their data effectively, regardless of scale or complexity. This ensures that data remains reliable, secure, and strategic asset across various applications and environments. Management systems come equipped with a range of features designed to ensure efficient, secure, and reliable data management across various industries. Here are the commonly implemented features and their purposes. Data storage and retrieval allows for storage of large volumes of data in a structured manner, making retrieval efficient and reliable. Transaction management, which ensures the integrity of data by implementing asset properties, atomicity, consistency, isolation, and durability, allowing for reliable concurrent transactions and error recovery. These features collectively ensure that a DBMS can support complex, large-scale data environments, providing robust data management, security, and analytical capabilities to meet various organization needs. Different types of database management systems are designed to handle various data management needs, each with its unique characteristics and use cases. Here are the primary types of DBMS and their characteristics and examples of their use. A higher oriented programming and database technology storing data and objects. These types of database support data types, classes, inheritance, mirroring object-oriented programming paradigm. DBMS are used in engineering applications and computer-aided design systems where complex data objects and their relationships can be efficiently managed. Then we have a NoSQL DBMS. It is designed for handling large volumes of data that do not fit into traditional RDMs. NoSQL databases are scalable, provide higher performance for read or write operations, and can handle unstructured and semi-structured data. An example of this case would be like MongoDB. MongoDB are used in content management systems and e-commerce platforms where each document can store different data structures. Key value stores such as Redis are utilized in caching and session storing scenarios. Column family databases like Cassandra are employed in handling big data workloads, offering high availability and scalability. Graph databases as Neo4j are used in social networking analysis, fraud detection, network analysis, where relationships among data points are crucial. Each DBMS type offers specific features and functionalities tailored to different data management requirements, from structured data in relation to database to highly connected data and graph databases showcasing the diversity and adaptability of database technologies in various domains. DBMS end user tools are software applications or utilities that enable users to interact with databases to perform various tasks without needing in-depth technical knowledge of SQL or database design. These tools provide user-friendly interfaces and functionalities that cater to different types of users, from database administrators to casual user end. So some of the tools that we have is a query tool. These tools allow to write and execute SQL queries to retrieve, update, and set or delete data. They often provide a user-friendly interface to construct queries without writing SQL code manually. Report generators, on the other hand, users can use these tools to design and generate reports from data within the database. They typically offer a graphical interface to select, organize, and present data in various formats. Data entry forms. These are designed for easy data entry and modification. Data entry forms provide a simple and intuitive interface for users to input or update without directly interacting with the underlying table.
For our project, we opted to use a relational database management system because they are one of the most commonly and widely used persistent mechanisms. They can handle large-scale, multi-user, multi-application implementation that replicate their data across many servers to ensure that data remains accessible even in the face of machine failure. All right, and so to understand a bit more on the key relationships between the table within the database structure, we'll look at our world table to start off with. As you can see that each world gets an ID, and the world ID in this table, this is the primary key for all the world. Once the world name has been assigned and all the other parameters, an ID is allocated to that world. Then moving on to the world's objects table, this is whereby you get each object gets an ID. So each object has an ID, and then we specify the ID type, and then we look at the foreign key, which is the world ID, which is a foreign key in the world objects table. It links the object to the world, and this is how we identify which object belongs in which world.
Good day, my name is Sado, and today we'll be talking about evaluating SQL implementation and data management in web applications. In this section, we talk about SQL and how we use it to create tables with columns and rows to organize data of the robot world. So the actual table needs to collect data and organize it in a way that is readable. Data such as the type of the robot that the client is using, the name of the robot, the weapon the robot uses, the visibility of the robot, as well as the position X and position Y. And we continue and add the reload, how many times the robot reloaded its weapon, how many times did it got repaired, and so forth. And our first question is, does the demonstration showcase the implementation of the program design for your program using SQL? Yes, it does. To answer this, so we took a snippet from from our program code and of how we create a table, right? So this is a class that shows how we create a table called world objects. So it does say here we use updates, which is a framework, a framework from our library. We then say create table if not exist world object. This means that create a table if it does not exist. Create a table named object world object if it does not exist. But if it does exist, then it'll then throw an exception. So this table is supposed to have an ID integer, which is not null. It's supposed to have a object type, which is a var character of 225 characters, and not anything more than that. And then it goes and have the world ID, the X position, the Y position, the ops size. These All of these are supposed to be integers, and they're not supposed to be null, meaning that they're not supposed to be empty columns. And our next question says that does the demonstration showcase SQL code that is understandable? Yes, we also took a screenshot from our code that shows that the code that we wrote using SQL, it is understandable and it's readable, even for people with basic knowledge of programming or basic knowledge of SQL. They're still able to read and understand what we were trying to do. So in this class, we used insect. So insect as a whole, it does tell you that you are putting something into something. So it says insect into worlds. Worlds is another table, right? So the worlds, it's supposed to have the world name, the size, the visibility, the reload, the repair, and the mine. And then it goes and then they after in those columns, it'll then have rows. The rows will then be the values. With the values, we have so the world name from the values will go into the world name from the columns. So then the size, the visibility, the reload, the repair, and the mine, and so on. Our next question says, does the demonstration showcase the use of SQL functionality that optimizes quality, that optimizes queries? Well, yes. An example of SQL functionalities that optimizes queries would be the use of indexes. Indexes are special lookup tables that the database search engine can use to speed up data retrieval. And in this screenshot that we used from our code here, we used select. So what we mean with select is you're actually selecting something specific from somewhere, and then you have to focus on it as it is. So when we use select, we know that, for example, we'd say select size from world. So meaning select size, take size from, or focus on size from world. Our next question is, does the demonstration showcase SQL functionalities that make the SQL code understandable? Yes, SQL functionality that enhances the understandability of SQL code is the use of aliases. Aliases in SQL are temporary names given to tables or columns, right? For the duration of a particular query. They make SQL statement more readable and conscious, as well as especially when dealing with complex queries involving multiple tables, or when the column names are lengthy or not descriptive. And we took a screenshot from our code here where we use for example delete. When you know when we use delete, it means that we're removing something from somewhere. So here we're deleting from world, which is a table that we created, which is called worlds. So we're deleting the ID from, which is a column ID in the worlds table. And our next question says, does the demonstration show the necessity of each table join SQL query? Well, yes. I would say that in SQL, table joins are crucial for combining columns from two or more table based on a related column between them, right? Each type of join serves a specific purpose, enabling various ways to match from multiple tables. And here is we'll just explain as to which kind of join that we used and what do they do, right? We have inner join. Yeah, an inner join retrieves rows with matching values in both tables, combining related data based on specified conditions. Right, and then we have the left join, which retrieves all rows from the left table and unmatched rows from the right table with null values for unmatched rows on the right. We then have a right join, which is the opposite of the left. It retrieves all rows from the right table and matched rows from the left with null for unmatched left rows. And then we have a full join, which is a combination, or rather it combines left join and right join, returning all rows with matches from either table. We then have a cross join, which returns a Cartesian product of two tables combining every row of one with every row of the other. Lastly, we have the self join, which joins a table with itself, useful for comparing rows within the same table. Says that the demonstration identified the method of accessing data from your program. So we used a screenshot here, and to answer this, yes, the showcase of the use of SQL functionalities that perceives the integrity of of data accessed by multiple users. Rather, we looked at our world data access interface .java file, which is a function whereby we create a table called worlds, right? And obviously, if it exists, as you can see, it'll then already, if it already exists, it'll then throw an exception. But if it does not exist, it'll then create it. Um, so in this SQL table that we create, it constraint is an evidence where we define the ID field as the primary key and set it to auto increment. This ensures each record in the world table has a unique identifier. And this, I would say that is very important for maintaining the identity and uniqueness of each world, right? Even if multiple users or processes try to insert new records at the same time, it'll still be unique because of the ID. And we also mark the field like fields like your world name, the size, visibility, reload, repair, and the mine as well, which they are all marked as not null, meaning that they're supposed to have some sort of information. Um, that the database won't allow users to insert or update any records where those crucial fields are empty, like they're not supposed to be empty at all. And our next question says, does the demonstration showcase good use of data sharing within the application? And to show good use of this, we look at the data to object converter class, right? Where we use three different objects. We have essential configuration object, we have the type list for world object. We also have a data conversion and management during the initialization. So with essential configuration object, this is the class where we use a world configuration object that centralizes configuration settings for the world, such as height, width, visibility, reload, as well as the repair time, right, and the mine time. This allows for a undefined point of reference for these settings, which can be efficiently passed around and used in the other parts of the application as well. And with the type list for world objects, right, it maintains separate list for different types of obstacles, which is the obs list, your mine list, and your pets list, and each list is tailored to specify type of objects in the world, facilitating I'd say organized and efficient data handling. This separation helps in managing the object based on their type, which can be crucial in rendering and intersection logic within the world, right? And lastly, with the data conversion and management, I would say that during the initialization, the data to object converter constructor, it takes raw data object, and then which is the world data do and the world object do, and it translates them into structured world configuration and obstacle objects. This conversion is a crucial step that allows raw data to retrieve from a database, right, and this is going to help them to be transferred into actionable object that the application can easily direct. Our next question says, does the demonstration showcase the underlying technologies that link database and websites? Yes. Here we show from our screenshot, we show that how we linked these two, right? We used a JDBC, otherwise known as a Java database convertibility, to connect to our web application program interface, right? Connecting to the database. The connect method establishes a connection to the database using JDBC. It then utilizes a driver manager.get connection to create a connection object, which serves as a gateway for for database communication, and it also initiates DAO, right, which stands for the data access object class, linking them. Linking them with the established connection. This setup integrates the database operation directly with the back end logic, right? It then enables data manipulation and retrieval through the DAO pattern, which is the data access object pattern. As you can see in line 53, this method initializes the connection to the SQLite database as directed by the prefix JDBC SQLite in this DB URL. And our next question and last, it says that the demonstration showcase code that is commented. Definitely yes. As shown in our update function, we used doc strings to comment and explain in more details what the function does, and gave step-to-step algorithm procedures as to how the function achieves this. As you can see, we have two screenshots from our code whereby we have doc strings and commented code, where we comment how each line and what each line does, right? And then we have an explanation at the top as to what the function does as a whole. And that's all from me for today. Thank you.
Assessing test plan execution and data access verification in computer program testing. Now we understand that JUnit is a Java testing framework used for writing and running repeatable tests. It's an essential tool in the practice of test-driven development and is one of the most popular unit testing frameworks in the Java ecosystem. JUnit provides annotations to identify test methods as well as assertions for testing expected results, making it easier to test our Java code systematically. Now, looking at the test plan, our objective was to ensure the robot world application's logic, database interaction, and socket communication work as expected and meet the requirements. The test environment, our development and testing environment, was set up with Java, JUnit, Mockit-O, an internal memory database, and the necessary network setup for socket testing. Continuous integration pipeline is configured with GitLab to run tests on each commit. To demonstrate the use of input data as specified in the test plan, we will look at our Web API class. As you can see here, it's tagged unit, so it falls under our unit tests. And we'll take a look at this function specifically, this test. So this test tests the getWorld function. Now we'll have a closer look at these two lines of code, which are the initialization of mocks. So a mock instance of the Web API handler and context is created. These mocks simulate real objects without involving their actual implementations. This isolation helps in testing the Web API handler functionality independently of its dependencies like the context. Moving right along to this line of code here, otherwise known as our method setup. This line configures the mock handler such that when the getWorld method is called with the mock context as an argument, it will perform no action. This is typically used to ensure that the method does not produce any side effects in the test environment. Moving on to this line of code here, otherwise known as the method invocation, this line calls the method being tested. Since the method is expected to interact with the context but not alter the state or produce a return value. So basically, this call is primarily for verifying the interaction. And then moving on to our last line of code, otherwise known as the verification. This checks that the getWorld method on the handler mock was indeed called with the context as its argument. It is also a way to confirm that the method uses its input data, which was the context, as expected. All right, so with this being said, I can also note that we did not have any deviations from the test plan during the testing, and everything worked out as expected. So what we will do is we'll run this test, specifically this test, using our JUnit framework, and see the result. All right, as you can see, there's three tests. There is the test get world with name, and test launch robot. And all the tests have passed. To show the testing of our code's logic paths and demonstrate the standards of procedures specified in the test plan for testing and retesting, I will simply run all our tests again. So these are the acceptance tests, and these are the unit tests. We'll run all of these with the JUnit framework. And while the tests run, I will specify that as a team, we managed to cover all the necessary tests and procedures accurately and thoroughly, showing effective use of tool, proper test execution, and alignment with our standards for documentation and reporting. This alignment affirms our testing framework's effectiveness and the application's reliability, giving us confidence in our development process and the quality of our software. All right, so 68 tests have run and 68 have passed with no errors and 0 failures. So moving right along, To show or to demonstrate the elimination of errors identified through the testing of database access using SQL, we will look at our world database objects test. All right. Now, having a closer look at our world database object test, you can see what is required before all and after all, where we set the connection and close the connection. Before each, we create a table. After each, we drop that table. We'll have a look at the test insert into world function. So what this function basically does, it inserts a column into the world database and insert some values. In this case, we are creating a column called test, and then we're testing if these values are inserted here. So basically, we are inserting into the world using the following SQL code or command, where we insert into worlds a world name, size, visibility, reload, repair, mine, and so forth. To demonstrate that our database access functions are in the required environment, we'll look at our world database access test class to closely inspect the functions. All right, as we can see, the class is tagged unit, so these are unit tests. You'll need a connection. Before all the tests, we set a connection, and after all the tests, we close the connection. Before each, we will create a table, and after each, we will drop the tables. Looking closely at the tests themselves, now we test if we can insert data into the world. We test if we can delete data from the database. We test if we can update the data within a database. We also test if we can get data from a database. So we basically follow the CRUD operations. And now to verify through testing that the database access performs according to the requirements, I'll simply run these tests isolated from all the other tests. And like all tests, I'll use the JUnit framework. All right. And to verify through testing that our database access functions all perform according to the requirements, we can assess the results of these tests. So we ran 4 different tests. We tested the delete world function that deletes data. We tested the insert into world function that inserts data into a database. We tested the update world function that updates the data in a database, and the get world function that gets the data from a database. As we can see, all 4 of these tests ran and none of them failed, thus verifying that all our functions meet the requirements. Now, to demonstrate that the records are produced for all tests executed during the testing of the software, we can look at our pipeline records, but otherwise we can also check in our targets folder right here. And under the reports directory, we can see the records of all the tests ran and their results. Now, to demonstrate variation identification, fortunately, our team had no variations and no variations were made, and all the tests ran according to the initial plan. All the recorded results can be reproduced by simply accessing this folder and under the reports directory, which contain the saved records and stores the new records of the reproduced rerun test results. And yes, indeed, it is through this method that we allow the results to be reviewed while testing. So a developer can access these results and review them while testing. After reviewing the testing process, here are 3 testing strategies to enhance the testing process of our project. The introduction and addition of these testing strategies will deeply enhance the testing of a software like ours. To begin with, we have integration testing, and its purpose is to ensure that different parts of the application work together as expected. Its implementation, we write tests that simulate the interaction between the Java application and the SQL database, checking the data flow and handling between the client and server. Secondly, would be a system testing. Now, the purpose is to validate the complete and integrated software product. Its implementation is to conduct end-to-end tests that include user interactions from the client side through the server to the database, ensuring that the entire system functions correctly under real-world scenarios. Thirdly, would be the performance testing. Its purpose is to ensure that the system performs well under significant load, and its implementation is to test how the system handles concurrent data across and manipulation, focusing on performance bottlenecks and systems behavior under load.